Okay, so let's go ahead and do the review for Unit 4. We're going to start with 4.1. 4.1 deals with chemical reactions. And so in this section here, we were looking at the ways that you can identify that a chemical reaction actually took place. So chemical reactions can be identified by various things. First thing is, how do you know that a chemical reaction took place? So what we need to look at here are signs that a reaction occurred. And so these signs can include things like the generation of heat. And remember here with heat, heat can either be lost or gained. And we'll explore this in a later unit when we look at whether that heat was lost or gained in terms of exothermic, endothermic. That's actually important in the thermodynamics of things. But the other item that you need to be looking out for is whether there was light being generated in the reaction. Other things that we can look out for are sound, and gas formation is another one. And so these things here will tell you that a reaction occurred. The other item that you can look for here is going to be a color change. And so color change is also important in that identification. And then one of the key ones here that was useful in the previous section was the formation of a precipitate. And I'm just going to abbreviate that as PPT for precipitate. So these are the things that will tell you that you actually have a chemical reaction that actually occurred. The next thing that you need to be aware of here in this section is the changes that occur. There's two general types of changes, and let's move some of these items over here to the side. And the first change that we need to be aware of are physical changes versus chemical changes. And so these two are very important. Keep in mind that when we're dealing with the physical and chemical changes, there's two things that we really need to be aware of. The physical change is a change that does not change the identity. And so here, change in which the identity of the compound or the substance is not going to be changed. So not changed. Okay. The other item here is with the chemical. Chemical actually is going to have a change here. And so when these changes occur, this is a change where the identity of the substance is going to be affected. Okay, is affected. What happens here is that you're going to wind up getting a different substance altogether. So the original identity of that substance is no longer occurring. So if these changes occur here, the one on the left is known as a physical change. And if there's a change that involves a change in the identity of the substance, that will be a chemical change. There, like that. All right, so the next thing that we needed to explore here, let's move this over here to the right-hand side, is that the chemical reactions involved 5 key reactions, which we labeled the 5 big ones. So let's take a look at the types of chemical reactions here. So types of chemical reactions. And there were 5 of them. The very first one was a synthesis reaction. And remember, the synthesis reaction involved a substance A reacting with a substance B, and this was going to form a compound AB. Here, the distinction is in the compound that the positive would be associated with the first one, which would be A, and then the negative part of the compound would be the second part, which would be B. The second type of compound was the reverse of this one. When the compound AB got broken apart into A and B separately, this was known as a decomposition reaction type. And so the reverse is true here, where AB was broken down into A and B, but here we would have A in the plus form and B in the minus form. The third type of reaction was a single replacement. And so let's go ahead and put it like this. And in a single replacement, we had AB compound reacting with a substance C. And here we would have C combining with the B, and then we would have A that would be isolated all the way around. And so let's go ahead and make this a little bit smaller here. Let's make this part over here. Oh, I guess we'll have to rewrite everything over here like this. Not a problem. So here the fourth type of reaction here would be a double, and this would be a replacement. And the double replacement here would be when you had AB reacting with CD, and then the products here would be CB and AD, right? The fifth type here was a combustion reaction. And the combustion reaction was when you were able to take a hydrocarbon, for example, CH4, and you reacted that with oxygen. This would give you two products here, carbon dioxide and water. Now, you would have to balance this out overall to make sure you had the right number of carbons on both sides, oxygens as well. But in essence, the products that are going to be formed are going to be water, and this was with a little bit of heat, so heat is applied there in the triangle. Now, this section also allowed us to kind of talk about a couple of other reactions that were part of the later sections, and that would be the following. So let me make some space here. So the next thing that we need to do is kind of, all right, so the next thing we need to consider is how do this reactions or these reactants and products, how are they related? So in order for us to consider that, let's just take the generic example here, say with a double replacement. So we'll have AB reacting with CD. This is going to form here AD plus CB. We need to consider here that there are a set of numbers at the beginning of each of these. And remember, we had said in this class that these numbers here represent the coefficients. And each of the coefficients was giving you the number of copies that were available for that particular compound. There were another set of numbers that were identified for each of these, and these were the numbers here at the bottom, and I'm going to write them in blue. Now, all of these numbers here appear just to the bottom and to the right of each letter because each of these represents what is known as a subscript. And the subscripts tell you the number of copies of that individual atom. And so one of the main things we needed to understand here is the relationship between the compound and the atoms in that compound. For example, let's say that we had here H2O. In this example here, we've got one copy of H2O. So what we would say here is that here we would have one copy of H2O, but this one copy is going to be composed of two copies of hydrogen and one copy of oxygen. And so the ratio here between the compound and the individual atoms can be written as the following. So we would say 1 of H2O for every one copy of oxygen, or we could say 1 copy of H2O for every 2 copies of H2O. And so let's go ahead and write that as H. And so here we can see the relationship is between the copy of the compound versus the copy of individual atom. And here I am using the word copy very loosely. What I'm really referring to here is the number of moles, which is the way it should be written. So another way of doing this here is to see what happens with, say, another compound. Let's say instead of having one of these water molecules, what if we actually had multiple copies? And so let's kind of move this up here to the side, and let's kind of do this. So here, this time around, next example, we're going to say that we've got 2 moles of H2O. Here the relationship is for every 2 moles of the H2O compound, we are going to have 2 moles of hydrogen. And so this is going to be, so 2 moles of this is going to have 2 moles of that. And this is going to be H2. And then for every 2 moles of H2O, there's going to be 2 moles of oxygen. And largely the reason that this is the case is because we've got 2 copies. So when we have this, we have to actually consider what it really means at the end of the day. And so this means that we've got H2O, and then we've got H2O. And so you can see here, if we've got 2 copies or 2 moles of the water, we've got 2 plus 2, 4 copies of the hydrogen, but individually we've got 1 copy of H2, 1 copy of H2. So here we would have a combined effect of 4 hydrogens. And so we could amend this then to say 4 moles of individual hydrogen atom. And so the oxygens here, we've got 1 and 2 oxygen atoms for every 2 copies, and so this one here is appropriate. But the relationship overall between the compound is 2 to 4 if you're looking at individual hydrogens. Okay, so this is the one thing that you want to be able to do. Remember that we can identify mole ratios in all of this, and it's those mole ratios that are going to be needed when you're doing some of the stoichiometry that will come up here pretty soon. The next item we want to do before we move on to the next section of stoich is to look at the reactions. How do you balance? So let's look at a couple of examples in balancing. So let me make some space here. Move some of this stuff out of the way. Here at the very top, let's just move everything to the right. And then we'll do the same thing here. And then we'll use this space down here at the bottom. I've got a reaction that I want to look at. This is one that we had done in the past. So let's see here. We have an example. The reaction would be C2H5OH. This is going to be added to oxygen, and it's going to produce carbon dioxide and water. And so the main thing that we want to do here for balancing is you want to start with an atom at the very far left, count the number of atoms. In this case, we have 2 carbons, and we have to look at the right side where the carbon is found in any of the products. The carbon's only found in the carbon dioxide, so we have to look at here. We've got 2 carbons, so we would need another copy of the carbon. But since the carbon is bound to oxygen in a molecule, we would have to put a copy of the entire thing. So I'm going to put this here as a CO2. Now we look at 2 carbons on the left. We've got 1 carbon, 2 carbons. So at least with respect to the carbons is balanced. We move our attention now to the hydrogens. Here we've got 5 hydrogens here, plus 1. That means 6 hydrogens over here on the left-hand side. And on the right, we've only got a copy of 2. So we would need to add here another copy. H2O right there. And so if you look at that here, we've got 2, 4, 6 copies of hydrogen on the right-hand side. 5 plus 1 is 6. And so all that is left to balance at this point is to balance the oxygens. Oxygens here, we've only got 2 on the left, but now we've got 2, 4, 5, 6, 7 on the left-hand side. So if we write an equation here, we're going to see that the value here for the coefficient is x. So if I take x, and I know I've got 2 copies for each 1 copy, this is going to have to be equal to 7. So if I divide by 2 on both sides, the x value here is going to be 7 halves. Now remember that we cannot have fractions when it comes to atoms. So what we'll do here is I'm going to go ahead and erase the x. I'm going to replace that with a 7 halves. But keep in mind that we're going to have to make sure that we double all of the numbers to make sure we get rid of that half. So in the meantime, let's go ahead and count the copies. So here we've only got 1 copy, so that's why I'm writing a 1 down. I've got 2 copies of the carbon dioxide, so I'm going to go ahead and write a 2 coefficient. And then lastly, the waters, I've got 1, 2, 3 copies, so I'm going to write a coefficient of 3. Now, let's go ahead and deal with the 7 halves. We cannot have a 7 halves, so in order to get rid of the 7 halves, I have to multiply by 2. So I'll do that here, and I'm going to say here, I'm going to put this in yellow, so I'm going to put here times 2. That will cancel here, giving you a number of 7 for the coefficient of the oxygen, but I need to do times 2 on all of these. So that would be a times 2, giving you a coefficient here of 2 for this compound, times 2, which will give you 4, and then times 2, which will give you a value of 6. So our overall numbers are going to be 2, 7, 4, and 6. And if we write those individual compounds back in, this would be C2H5OH. O2 goes to form 4 copies of carbon dioxide plus here 6 copies of the H2O. And so in this particular case, we would have the final balanced reaction, this one down here at the bottom that I'm going to put in the box. So here is what we're looking for. So this is what you want to go ahead and do in terms of balancing. Make sure you're able to do this for these kinds of problems, and there'll be plenty of those for you to have. Just make sure you can look for the answer. If it's a multiple choice, you want to look for the ones that have the numbers of 2, 7, 4, 6. Sometimes they ask you for the sum of the reactants, so that you would add 2 plus 7, that would be 9. Or they ask for the sum of the products, which is 4 and 6, which would be 10. And in other cases, they ask for the sum of all coefficients, in which case you would have 2 plus 7 is 9, and then 4 and 6 is 10, which would be a total of 19 for this particular problem. So that would bring us to the end of section 4.1. We'll continue here with 4.2 in the next video.